Welcome, everyone. Thanks for joining us. This is part of the Diamond List Spotlight series. Today, we're going to talk about sustainable fashion. I'm Zeina Fayyaz Kim. I'm one of the co-founders of Diamond List. I'm also actually an early stage climate investor with a group called C3 and working on a climate themed real estate development project you see behind me in New York State. But today we're talking about fashion. It's a topic I am personally really interested in. Seems like many of you are as well. If briefly, any of you did not, clicked on this link and did not have context for what Diamond List is, we are an annual list of climate companies nominated by top tier climate investors. And that's really the magic of this thing, is that the investors have a chance to signal to each other what they think is interesting, what they think is strong and worthy of investment, and hopefully catalyze investment. That if someone couldn't do this particular deal in this particular moment, someone else has a chance to do so. So that's what we're trying to do, is catalyze investment and support for these companies on the list. You can check it out. It's at diamondlist.co. We're actually going to be refreshing the data next month, so you'll see an update there. And certainly if you have ideas for how we can collaborate with you, your organization, any feedback today on today's session or anything else, please shoot us an email, hello@diamondlist.co. All the co-founders get it, and we'll get right back to you. So that's a bit on Diamond List. As for today, we're going to be spending the next few minutes on just a quick industry overview, and then we'll give each company a chance to tell you about what they do, answer a few questions before we go on to the next one, and finish up with breakout rooms, which just gives all of you a chance to, process what you heard today in a group of similar, like-minded people interested in sustainable fashion, or just have a nice chat together. And for our speakers today, I've got their pictures here. Beth from Unspun will be kicking us off with the industry overview, then handing it off to Brooke, who's actually going to speak more specifically about Unspun, Alexia, and Jen. Really excited that there are 4 amazing female founders and executives that we are getting to hear from today. Is unusual in climate space and climate tech. So this is just a great way to highlight some of our female founders, although totally coincidentally. And I'll let each of them introduce themselves when it's their turn to speak. So we're going to do a quick handoff. Beth, are you ready to share your screen?
Yeah, let me see.
Yes, stop first.
I'll take it away from you.
Okay.
Stealing the screen here. Cool. Hi everyone, I'm Beth. I'm one of the co-founders of Unspun. I'm really excited to be kicking this off today to really set the stage and give you a little bit of a historical context on the fashion industry before we hear about these amazing companies that are being worked on. So really basic level, why we wear clothing. We wear clothing for so many reasons, but kind of the main reasons are for protection. They protect us from the elements, from the heat, the cold, the rain, the wind. Another is self-expression. It's kind of a visual body language, if you will. And the third is really modesty. If you think about it, like if we didn't kind of fall into the social norms of our community, we wouldn't really fit in. So these are kind of the main reasons why we wear clothing. And no other species on Earth wears clothing that we know of. If you know of examples, please let me know. I'd be so curious to see if there are other animals who wear it, but it makes us very unique. So getting into the history, on the left here, you see a hide, and this is really the first clothing. And this is something we would take from our kill, right? We would kill something and then we would get the hide. And we would just drape it over our bodies. It was very primitive. But eventually we built tools. And this is actually something that differentiated Homo sapiens from Neanderthals. We're a little bit closer to Homo sapiens. They developed tools. So they developed needles and things to cut with. So with that, we're able to kind of cut and sew and build products that were better fitting and protected us more. And that's actually a theory for why Neanderthals died out, was because they didn't develop these tools. They weren't able to protect themselves as well as the Homo sapiens did in actually covering themselves. And then eventually we also found natural fibers. So we found fibers in the wild. We found that they could felt together really well if we used friction. And so we could create kind of mats of clothing, create shape that way. But we also found that we could twist them together and make these long pieces called yarn. And with yarn, we could start to knot and kind of tie things together. Eventually, we moved kind of from knots and knot binding into things that we use today, which are really, that's knitting and weaving. Knitting and weaving is like what you see most clothing made from. And it's believed that weaving was developed in Egypt because what had been developed to that point, which was really the knot binding and the knots, it just captured too much heat, like too much air. And so it was too insulative. And so they needed something that gave them a little bit more breathing room. And then something that you'll see throughout this timeline is that machines start to become very, very prevalent in the industry, and they speed things up even to today. Automation is just has made everything much more efficient. And so that ties in here with the cotton gin, the jacquard loom, which is the precursor to the computer, which is pretty cool, and the sewing machine. These were all things that sped up the industry, and they took the hand making out of particular aspects. So slowly machines take on more and more. And the sewing machine itself was huge because no longer were you stitching, like, I don't know if anyone, I'm sure people here have stitched things by hand. It takes forever. So the sewing machine was a huge change for the industry. And it was actually the reason why in 1900, the biggest industry in New York City was the garment industry. That was really carrying all of the jobs because so much was being produced. And so at that time, we saw department stores also pop up. Before then, we couldn't really make enough clothing to encourage people to be buying a lot. They were making stuff at home. And now with department stores, we could consolidate a lot of these mass-produced goods, put them in one place, and kind of give it a platform for people to come see what was the newest styles. And so at that point, we saw styles, we saw seasons change from, well, there weren't even really seasons before the sewing machine. You would have like every few years, maybe like every decade, every few decades, you would see styles change. But at the turn of the century with department stores and with sewing machines, these were now seasons that were like yearly or even like within the seasons that we think about, like, you know, fall, winter, spring. So that became a huge, huge change. And at this time, so at 1900, about 15% of the clothing that we wore, or 15% of our income was spent on clothing. So just keep that in mind. It's a pretty big number. So up to this point, so this is early 1900s, and then getting into kind of the mid-century, the mid-1500s, mid 1950s, all the clothing that we wore was made of natural fibers. So these are materials that are sourced directly from our planet. During the big world wars, especially World War II, that's when we started to, you know, synthesize new materials and make synthetics. And man-made fibers quickly became the norm. Today, we see that over half of clothing is made from polyester, for example. So it really took over. And these synthetics offered really new characteristics for us. They offered sweat wicking, they were affordable, they had stretch. So there's a lot to love about them. Of course, now we know there's a lot to hate about them, but at the time they really took over. And some examples were that rayon imitated silk, so that made it cheaper. Acrylic imitated wool, and then polyester itself was like a whole new material. And people spent at this time about 10% of their income. So down from 15% at the turn of the century, 10% of their income on clothing. So these synthetics really cheapened clothing. There was even a fad here that you can see with disposable clothing. So they just made non-wovens, pump them out, and then you'd wear it once and throw it out. Fortunately, that fad did not survive very long, but you could relate it to fast fashion today. Maybe it's a more honest version of fast fashion. And then something else that was big around the mid-century was Sears and Montgomery Ward catalogs. They really were able to bring down prices because of, again, using synthetics and pairing that with mass production. So they were able to hit those economies of scale and get those out to people very quickly. So as in 1955, for example, in the Sears catalog, a dress sold for $16, which is about $130 today. That was very, very cheap at the time. So, and the other interesting thing is that was probably also made in the US. About a majority of what we wore in the mid-century was also still made in the US. And that's going to be a turning point that you see in the 80s. We started to get a lot more communication through technology, and that really pushed us to globalization. This is kind of an image of what we see today. In our industry, this is globalization. You can kind of define globalization as like the spreading of products and money, technology, et cetera, across borders. And it was really picked up by the fashion industry in the 80s because of, it was cheap and you could skirt regulation very, very easily. So because the fashion industry, and especially sewing by hand, so we say sewing by hand, sewing by sewing machine, which I consider sewing by hand today. It's arguably the most labor-intensive profession in the world. So it became a very prime candidate to offshore because it's so labor-intensive. Those that did this survived. Those companies that did this survived. Companies that didn't globalize, they pretty much died out, which is really unfortunate. So a trend that we saw is that, of course, clothing got cheaper and cheaper. People started buying more, and it became this very, very vicious cycle, downward spiral. Order quantities went from in the few thousands to the almost millions, hundreds of thousands, maybe millions at a time. So a ton of production. And companies did this because it was so cheap. It really just made sense for them to mindlessly make stuff, just pump out as much as they could. If they didn't sell something, it didn't matter because it didn't cost very much money. And then with how low quality and trendy the garments were, consumers needed to come back more frequently to buy things. So suddenly we're moving from seasons that we were talking about seasons previously from, a few decades to seasons like the seasons we think of on the calendar to now weeks or even days. So for example, Zara has a new line drop every 2 weeks. H&M and Forever 21, they're replenishing daily. And then Topshop gets 400 styles every week, which is out of control to have that kind of turnover. And we've just gotten used to it. Like we go into a store, we expect to see new stuff every time. So remember that people were spending about 15% of their income at the turn of the century in the 1900s. Now they're spending about 1 to 3% of their income on clothing, even though everything else in our life has gotten more expensive, like housing, gas, education, all those things are much more expensive. But even ignoring inflation, we spend less money on our clothing than we previously did. So here's a graph kind of showing pretty obviously why we've offshored. Bangladesh, which is the third up from the bottom, that's where you'll probably, maybe not everyone here, but a lot of labels are labeled Bangladesh for the reason that it's a very established industry there and they're very cheap. But look at Ethiopia. They're going to be taking over in the next few years because just economically it makes more sense for these companies to be making there. And then on the top you have Turkey and China. Those ones you saw on labels like 10 years ago, they were everywhere. But now they're only a quarter of the cost of what it takes to produce in the US, which is very expensive. That's very expensive for the clothing industry to be just a quarter of the cost. So those ones are well on their way out. And only 2%, so for this reason, only 2% of what we wear in the US is actually made here in the US. It used to be a majority, about 95% in the mid-century, so 60, 70 years ago. And now we're only at 2%. So because it's so cheap to make overseas, it's kind of a no-brainer that we would just keep making more and more. So around 2000, we made 50 billion garments. And then not even 15 years later, we doubled that number to 100 billion garments. And we're now well beyond 100 billion garments. We're just making too much stuff. So that's a huge problem. But then pair that with the fact that the life cycle or lifeline is not actually a cycle, it's completely linear. So we have no plan for what we do with the products that we make. We really don't design them for circularity. There's just nothing in place yet to do this. So this not only contributes, of course, to waste, but also to pollution, carbon emissions, resource use, and exploitation, all because you have to start over again every time you make a product, and all products are destined for landfill or incineration, I guess, if you're lucky. So this is a super pivotal time in fashion. We could go way downhill where we're taking currently 92 million tons of waste per year. And we would make that into 134 million tons of waste per year by 2030. That's what we're slated for right now. Or we could instead support the companies like you're going to see today, the promising new initiatives that will enable a circular fashion economy. We need epic changes. We really need an overhaul to make this possible. So I'm very excited to see these solutions today. Thanks, guys.
Thanks, Beth. That was such a good overview. Really excited to have this recording so that people can reference this later. For sure, I would love for Brooke to jump on next and talk specifically about how Unspun is going to be combating some of these unsustainable patterns in fashion.
Great. Can everybody see my screen?
Yes, we see it.
Great. Yeah, excited to talk about Unspun after Beth's awesome intro. I'm lucky enough to work with Beth at Unspun as product lead, and Unspun's been around for a few years, and we're trying to tackle a lot of the problems that Beth went over in the intro. We're building AI and other tech to make custom fit and on-demand possible in the fashion industry. And we're going to talk about a little bit why that matters and why we've chosen that path. So first, the fashion industry is really interesting with size and guesswork, right? So Beth talked about how we used to always make things by hand, which meant everything was made custom. But now, essentially, you're taking a fit model that has almost impossible proportions, and then you're making graded sizes, and 99% of the world's trying to squeeze into this person's proportions, right? And this is the reason why we have returns. This is the reason why you might own 5 pairs of jeans but only wear 1. So the sizing and how we think about bodies is actually contributing to waste more than you might think. Also manual labor. So Beth also touched on this, but this is what tends to be squeezed the most in the fashion industry. This is why companies are moving from China to Bangladesh, then Vietnam. They're moving to places with, lower minimum wages, but also less regulation on the social and the environmental. So we're really creating this race to the bottom, and workers are suffering because of this model. So that's something that we think about a lot. And then another is obviously, waste production. There's so much, when you're trying to turn around and guess the trends and you're trying to produce multiple collections per week, sometimes they're just not going to hit. And that is built into business models that is okay, that 20 to 40% cannot be sold at full price, which when you think about business models, the fact that is so ingrained in fashion is kind of mind-blowing. So when we think about this, all these questions come up, and we really want to test the, how might we build on demand and how might we build a circular industry? And we know that it's not just one piece of the puzzle, it's multi pieces of the puzzle. So we're trying to really bring them all together. And our mission is to reduce the global human carbon footprint by 1%, which is, it's big, right? But, we really want to put a stake in the ground, and we really want to, run as fast as we can towards these goals, because it is important, and we should be shooting for these targets. So that's kind of every decision that we make, we go back to this 1%, and it is our guiding light. So a little bit about our process. So instead of starting with the product as in traditional, we actually start with the customer. So we don't make anything until it already has a home. So, and we don't make anything that's, based off other people's proportions. This is based on you. So how it works for us is that you build your pair of jeans, you pick your style, fabric, thread. It's a very personalized process that our customers really enjoy. And then you get a body scan. And the body scan is not just a hip measurement and a waist measurement and a thigh measurement, because there's a lot that goes on, between these measurements. So we look at the body as 10,000 data points, and we 3D map to that. And we have accuracy to the millimeter, because really, everybody's body is different. It's not just about key measurements. And then, we really work with, our customers to love the jeans, right? Like if these jeans are amazing, and you do have to pay a little bit more for them, are you going to buy less? Are you going to keep them longer? Are you going to value your clothes in a different way? So we have all these conversations going on with our customers. And very, informative through our website, through our emails, through our hang tags, really trying to push this as well. So, and here's a little bit more of our process. So on the left, you'll see how you can customize the scan, and in the middle, we have scanners in store, but recently we just launched mobile scanning as well. So you can do it from your own home. It's quite fun, if you ask me, but I'm kind of a tech fashion nerd. And then we are working on kind of mapping it to your body as well. So, how to match, your body to an avatar so that you can actually see what it looks like on you, and make the best decision for your style preferences and subjective concerns. Yeah, and then it's just a flashy fun image. And then, so we do this through our own brand, but we also do this through B2B partnerships, because we feel that, we would like to kind of shift the fast fashion industry while setting like precedent as a smaller growing brand as well. So we really think that both are important. Here's an example of a launch that we are currently doing with H&M. So they have a store in Sweden. People are coming in and getting body scans. And so this line that we have with them, it creates no inventory waste, which for a fast fashion brand like H&M, this could be huge, right? As far as waste goes, if you can really get them to think a little bit differently, that's really exciting. So we're excited about this, and also their customers that are coming in that wouldn't traditionally be able to buy sizes in their store are able to then participate and get these garments. So that's been really exciting. And we also have other exciting partnerships, but we can't talk about those just yet. Stay tuned. And then here's just a quick video on kind of how we collaborate, right? So we know that just on demand and custom isn't enough. We really need to think through the whole value chain, and Unspun very much values collaboration, because we all can't do this alone. We have to join forces. So here is just a video of a larger collaboration that we've done. And that's just an example of how we're trying to think through the process. So when you give your jeans back to us, we can dissolve the thread, we can remove the button, and we can reuse that. But it takes a lot of players to kind of get this off the ground. So just an example there. And then this is the last slide here. So Beth kind of showed the first version of this, where we're at now. And then on the right is where we believe that we can be. So if we can start making things that can be recycled, the stitching can be removed, then we can even start thinking beyond that. And actually at Unspun, we have an entire hardware team that is making a 3D weaving loom. So eventually our software will connect to the loom and we won't even have cutting waste. And long-term vision is, what if you could weave something and then unweave it at the end of its life and use that? So that's kind of our long-term vision of how we can play a part at a circular fashion industry. Thank you.
That's incredible. Thank you, Brooke. If anyone has a quick question for Brooke, you can raise your hand, use just the reaction, and I'll try to find you and call on you, or you can drop something into the chat. I'll give folks just a minute if they have a question. And if you don't have a question right now, you can also save it for the breakout rooms, or we can try to get you an answer on email later. Okay, I think this was just a really thorough presentation, Brooke. So I'm gonna toss it over to Alexia. Let's talk about leather.
All right, let me get my screen up here. Can you guys see my slide?
Yeah.
Awesome, great. Thank you so much, Brooke and Beth, for setting things up. I think that's great, and I love what you guys are doing at Unspun. Very cool. My name is Alexia Krispin. I'm Chief Operating Officer at VitroLabs, and I'm here to talk about cultivated leather, how it fits into the value chain today, where we are as a company, and then, of course, how it fits into a more sustainable future in fashion. By the way, all of these pictures in here, I'm really excited. We recently took down a new batch of leather, so all of these are actually our leather that we've made from our hides. So starting out with a problem, we're here to talk about sustainable fashion, obviously. So leather is a $400 billion industry. Leather goods are $400 billion industry, headed toward about $600 billion in the next few years. The luxury industry, so that segment underneath the overall leather goods, is set to grow about 33% over the next 5 years. So it's the fastest growing luxury segment in the leather or luxury segment in the fashion industry. But one of the problems that we see is, this has been around for thousands of years. You saw in Beth's presentation how we started out as hides, and we've really just gone through globalization and really scaled up production of leather, but without changing the source of leather or really how it's made. And so with that, we are destroying the planet because leather as a co-product of the meat industry is per kilogram the most environmentally damaging material. So we carry through those environmental impacts that come from raising of livestock, and the leather industry is completely entangled with the meat industry today. So we have water usage and massive runoff, deforestation and displacement. So 80% of deforestation in the Amazon, for example, is just coming from pasture clearing for cattle and livestock. And then you have greenhouse gas emissions. So the livestock industry today produces more greenhouse gas emissions than all of the transportation industry, global transportation industry today. So huge impacts there. And then as well, you have unethical animal treatment, which I don't think I really need to get into, but big factory farms with animals crammed in where they can't really move. So on top of the problems with just the environmental aspect, there's also then the supply chain. So we've all been together experiencing the global pandemic, And we've seen just how fragile our supply chains are. And this is no different for the leather industry as well. So when you're sourcing hides from an animal and from a different industry, you really are completely reliant on what is happening in that industry. If there are zoonotic diseases, if there are culling of the herds, you lose a lot of that source and a lot of those raw materials. So what brands and consumers are finding is that they are really struggling to trace the source of their hides. So it's really hard to know where they're coming from. Some are coming from illegally farmed land, and places that are not necessarily the most ethical way to raise cattle. Also wasteful and expensive. So when you think about a hide, I think it's really easy to separate the hides from the actual finished product. But the hides grow in this kind of wonky shape, of course. They grow in the shape of an animal. And then you have to take them from this 3D animal, flatten them, remove a bunch of layers. They have fur, they have fat, etc. And that's really where you lose, 40 to 60% of the hide on average. So a lot of it is cut away, wasted, and it's hugely expensive for brands and impactful for the environment as well. And then, of course, going in, this is actually something that not very many people are familiar with, but when you go into those luxury high-grade hides, you're really finding that they're disappearing. So because of the farming practices today, because of how animals are put into these small confined spaces, you really have a lot of damage to the hides. So it's very hard to secure the product and enough product that's not damaged. So of course, we've seen a tidal wave of leather-like alternatives that have come out. This is not anything that's new. So this started about 60 years ago. We had and have pleather, so plastic-based leather, which is really focused on the ethical aspect of it, but obviously we found has a horrible impact on the environment in terms of the plastic aspect of it. Now we're seeing a lot of mechanical approaches, mycelial, which is mushroom leather-like alternatives, and fermentation, which are really now aiming to address this more sustainability aspect, as well as the ethical side of things. So there's been a tidal wave of these new companies. With that, though, what we're missing here is so leather itself. The hides are made up of a tapestry of proteins and extracellular matrix that really makes this beautiful complex organ, which is skin. And these different alternatives are addressing sustainability, but what they're not addressing is really that visceral quality that we've come to love. And this is the quality that, we've carried through since we started wearing hides, on our backs from our kills to today, where we have the look, feel, performance that we love about leather. So we ask, not how do we replace leather with a different material because we love leather, but how do we grow the hides in a much better way? So that's what we asked, and our answer is cultivating hides. So cultivating the hides for the source. So our mission is to make the beautiful leather that people have loved for thousands of years without creating the harmful impact that leather production has today. Very simple mission, making real leather. This is again another picture of our most recent batch that we tanned with some partners. So let's talk about the traditional process versus our process, and just to help understand kind of where we fit into the value chain, because I think that's very important. So when we're talking about all these environmental impacts, you really have to think about the 2 to 3 years that the animal is raised at the beginning of the process. So animals are raised, they need the water, the food, you need to grow the feed crop, and that is over that 2 to 3 years. Then the animal is slaughtered, it's skinned and bled. And so that is when we get the actual hides themselves. The hides are then trimmed and sorted and then sent over into this next section, which is the tanning process. Now, these hides during the 2 to 3 years, they grow, they use up the land, but then prior to or after slaughter, they get actually shipped from usually South America or North America. So the round trip of these hides can be up to 20,000 miles. So it goes to be processed in Asia typically, and then sent over to Europe to be finished and made into a final product. So while it does come from the meat industry, there's such another impact, or a large impact that comes from just the transportation alone and the processing after the fact. So jumping into our process, so cultivated hides come from a cow, but they are not grown by one. So what we do, we have this kind of parallel process, and you can see that it's passed on into traditional tanning, but with a reduced tanning process. So we take a one-time sourcing of cells from an animal, so we don't have to go back to the animal afterwards. We've immortalized the cell line, so we can actually produce enough cells to produce lots and lots of tissue for hides for years to come. We take those cells, we grow them up into a bioreactor. So you see in the second picture, we have a bioreactor, a large volume bioreactor. Think of like a big fermentation vat, where you can grow up a bunch of cells. And when those are ready, we actually move them into our proprietary platform. And that's really kind of the secret, where the magic happens. So you have a large scale tissue engineering bioreactor, and that's where we can seed the cells. So you think of it like farming, we seed, we grow, we harvest. So we seed the cells in this scaffold, and then we grow the cells just by giving them the environment that they would naturally have. So we give them the nutrients that they need, the temperature, et cetera, and that helps them stimulate to produce the proteins that are used for skin and hides. This only takes a few weeks. So the beauty of that is we can set up our platform on the spot where it's going to be used, where the hides are going to be finished and tanned. We don't have to ship it around the world. We can do it right on site when we want and where we want. And we can dial up and dial down production as needed. Then we go into passing on these hides to traditional tanning. Again, we can build our platform right next to the tannery, so there's less travel. And the other beauty of this is we don't have to remove any layers. So we only grow what's needed, and we don't have to trim. So what that means is we have a lot less waste, and we use way fewer chemicals when it comes to tanning, because you don't actually have to do all of the removal process that is very, very caustic, and it has a lot of different chemicals involved. Then we pass it on to the tanning, where the hides are salted, pre-tanned, and the artisans really get that flexibility to finish the product into a glove or into a car seat, which really the versatility and flexibility comes from that tanning process. So that's incredibly important, and we want to make sure that artisans maintain that kind of flexibility. And then we have finished leather. So I'll finish on this picture. I think it's really great to see kind of just a comparison of a traditional hide versus a cultivated hide. So these two hides are in the same phase. The top is a cultivated hide from our lab, and you see there's no hair, there's no fat. It's just what we'll use. Underneath is a traditional hide in the shape of an animal, and same color, it's gone through the same process, but still has the hair, the fat, etc. has to be cut down. And then on the right-hand side, you see the traditional leather that came from this traditional hide, and then you can see the cultivated leather that came from this cultivated hide. So that's where we are in terms of where we're headed. So right now, we've spent a lot of time, in product development, knocking out the quality, making sure that our customers are really excited about what we're doing, and now it's time for us to scale up. So we're hiring rapidly and scaling up our process as we go. And that is that. Any questions?
Yes, please. Raise your hand, use the reaction button, drop it in the chat, whatever you prefer. Thanks, Alexia. This was great. The visuals are so nice to see.
Thanks.
You're getting some enthusiasm in the chat. Okay, another really strong presentation, clearly. Oh wait, let's see. No, just technology. Great, awesome. Okay, well, we're a little short on time in any case, so I will let Jen jump in here. She's also growing things in a very different way, and she can talk about that.
Hi, everybody. First of all, I just want to say, I mean, how much I'm nerding out over these presentations. As a material person myself, it's so exciting to see how much progress has been made even in just the last few years. So I'm excited, and actually the order is very good for our presentations because I think it definitely makes sense. So I think you all, no, sorry, technical, there we go. I think everyone should see my presentation now. I'm Jen. I'm co-founder, CEO of Modern Synthesis. We're a London-based biofabrication company looking to evolve the way that we make fashion materials using biology, but in a different way than my counterparts on this call. And really, it's about, again, bringing together multidisciplines to rethink the way that we make materials in the future. Our aim as a company is really, as a designer myself, to empower circular design in the long run using biology and material science to enable this future that we've already seen glimpses of local and customized creation, but with infinitely renewable raw material inputs to help eliminate fashion industry plastic and chemical pollution in the future. Again, having been in this industry for a decade now, materials is one of the biggest drivers of CO2 emissions for fashion industry overall, as well as plastic pollution continues to be a struggle. Our approach is to look back at nature and see what we still can learn to rethink the way that we make materials. Instead of looking at sort of drop-in replacements, although the materials that we have, like leather is a great material, what can we think about the next step in materials? And for us, it's about going back to the basics and starting small and looking at the organisms that really began for life, such as bacteria, fungi, algae, and there's a lot of great companies in this space at the moment. But our approach is really looking at the organism itself and seeing how we can make use of the natural growing behaviors, in our case, a bacterium, to create a different future. And this is kind of going back to the early stages of the company and looking at not just what is the like how can we remake the materials we have today, but how can we show that actually nature is quite technical and can create a lot of really new aesthetics and drive sort of a different looking future. Our first technology is called microbial weaving, and this was inspired by an acetobacter bacteria that naturally grows a material called nanocellulose. And cellulose, for those of us on the call not with a material background, is the most abundant polymer on this planet. So it's in plants, it's in cotton, it's in wood. It's the basic building block for an incredible amount of materials. This particular type of cellulose, that bacteria grows, is 8 times stronger than steel and stiffer than Kevlar. So it's been interesting for scientists for many years for different applications. Also, the structure that it grows is quite interesting in that it creates this nano mesh that has inherent tensile strength properties because of the way that those fibers interact. But for me as a designer, looking under the microscope at how this bacteria grows, it reminded me a lot of a weaving shuttle. So trailing the fiber behind it and looking at how we can capture this natural growth behavior into new types of materials. So what exactly are we doing? So we create a fiber scaffold using traditional yarns as well as traditional textile capabilities. This is one example where we've used automated fiber placement, and this is really to create new types of patterns that wouldn't be able to exist before. And the cellulose grown by the bacteria is able to help hold that into new types of structures. We can also use traditional methods, which we're exploring now in our lab in Somerset House. The bacteria then grow a film in and around that fiber structure, interlacing the fibers to create this biocomposite, which then we press and finish into a really new material. And one of the exciting things about this material, talking to customers, is the transparency. So nanocellulose is naturally transparent and is very similar to sort of like a PU film in terms of the aesthetic, but with a much more natural hand feel. And so what we're targeting here is really this future of performance materials and how you can create these synthetic looking materials but with completely natural biodegradable polymer ingredients. One of the huge advantages here we see is the potential, again, for customization and being able to create a whole variety of different materials that are really a new class. So if we talk about knitting and weaving, this is really a new form of textile creation that sits sort of on the border between a non-woven and a woven, and looking at how we can use that to create a whole range of different textile products to sit alongside and help replace where leathers or synthetic leathers are used today, but again, with a completely new approach. Looking a bit further into the future, and my co-founder Ben's background, we're looking as well at synthetic biology. So this is an example where the bacteria that we use, we've genetically engineered to produce melanin, so a black pigment that's found in our skin and hair. So this is one of the first biomaterials that we know where the structure and the color are coming from the same GMO organism. And it's quite interesting because this bacteria in particular is very, was actually sequenced by my co-founder, and is very adaptable to growing in other properties. From a sustainability standpoint, we see this as an opportunity, again, to reduce process steps, but even further into the future, how we can create fundamentally new materials by actually growing in those building blocks directly. We're just at the early stages of our company, and we're looking to raise a seed round in a few months. So if you're interested in learning more about where we're at, what we're working on, feel free to contact me directly, or would love to answer questions as well if anyone's got any right now.
Wow, this is awesome. I got a DM that this was just really impressive to hear from all three of you. So thanks so much. Anyone have a quick question? Feel free to throw it in the chat. And if not, there's also a way that we can just have you interact with the founders in the breakout rooms. So that's an option too. If folks have to jump, by all means, feel free. We're going to send out this recording after the fact. But if you've got these 5 to 8 minutes left, I'll put people into breakout rooms now. And you'll have a chance to meet some others in this group. We do have one question, it looks like, actually coming in. Do you want to ask it out loud? You're welcome to.
Well, who are you referring to?
Either. Who's speaking right now? Sorry, I can't see you.
Hi, Jen. Yeah, my name is Annika, and a very impressive technology indeed. I wanted to know if your product will need any approval. Like, a lot of people have skin-related issues, and given that this is live bacteria, will there be any special requirements for it for approval?
This is a very great question, actually, but no. So this bacteria, I should have mentioned, is a bacteria that's commonly found in foodstuffs. So actually, kombucha tea, nata de coco. So it's actually edible and already produced for medical uses. So like wound healing. It's actually biocompatible as well, so that it's used actually internally. So it's a very sort of neutral material. In our process, we grow using the bacteria. It's a biofabrication process in that we use the bacteria to help create the material, but actually we wash out that bacteria at the end. So it's just pure cellulose.
Cool. So it's a good bacteria, and maybe people with eczema might benefit from it. Is that?
I mean, that would be great. We have not tested that, but definitely I see a lot of future for, I believe in good bacteria. So I think there's actually a lot we can still learn.
That's very cool. Thank you.
And Zem, did you have one as well?
Yeah, I have actually a couple, but just really quickly on the certification side, are you working with Biomimicry Institute or Cradle to Cradle certified?
Not yet. We have had an independent consultant. We've recently done a preliminary LCA and techno-economics analysis, but again, very early data. So hopefully we can expand on that future in the next coming years.
Okay, and then just two really quick follow-up questions about so Zymergen went public and then had a little bit of had some difficulty out the gate. And so I was just wondering, how are you going to address some of those concerns in terms of not really being ready for prime time? I'm super bullish on this. I just want to see that it's actually something that is really ready for the market, or the market's ready for it.
No, definitely. And actually, I think in our approach, so I talk about synthetic biology. Actually, the core of our technology right now is not based around the synthetic biology. It's around sort of the mechanical and sort of bio process of growing this bacteria into these materials. So in the short to midterm, we plan to build a product range around that without actually the synthetic biology side, but building that in for the long term. And I think the idea is how to stage a business development so that we can be ready when these technologies become commercially viable, and they will be. It's just sort of the time that it takes, and also making sure that we do that as consciously as possible.
Great, thank you. Okay, one last really quick question. Do you have the technology to 3D knit as well, or are you looking for partners who actually do the 3D knitting process? Because I work with one, that's what I'm asking.
By 3D knit, do you mean flat knitting, or?
Well, when you were growing the shoe, isn't that a 3D process?
No, actually, it's flat. So it's grown flat. We are interested definitely in textile technologies, so we can incorporate those into our process. So always looking for collaborations there. We don't have that capabilities in-house.
Great.
So
even better, there's a company called Variant. I'm happy to intro you. So,
yeah, cool.
Thank you so much. This is great. Thank you, Zeina.
Thanks.
That's what these events are for. Amazing. So I'm gonna pause, or rather stop the recording. Thank you again to the founders for presenting. I'll put folks who want to stay on into breakout rooms, and you all can see yourselves out whenever you're kind of done with the conversation with your group. But just wanted to say thanks again to everyone for being here.